Right?
It's going live. Just
Okay, fine.
5 seconds. Yeah,
Yeah.
we are live. Good to go.
Okay. Oh, so thank you very much for being one all. Today we have another wonderful talk on the celebration of International Asteroid Day. Today we have a special guest with
It's
us.
going live. Just 5 seconds.
Okay.
Yeah, we are live. Good to go.
Okay. Okay. So thank you very much for being one all. Today we have another wonderful talk on the celebration of Asteroid Day. Today we have a special guest with us.
Yeah, we are live.
Okay, so again, I'm welcoming our special guest, Dr. B S Shylaja, who is a visiting scientist at Bangalore Science Education Association, and who is a visiting scientist at Jawaharlal Nehru Planetarium Bangalore. So she's going to discuss about why we should study about asteroids. Today talk is really it will be amazing, going to be amazing. Yes, madam, it's time for you. Yeah, thank you. B.S. Shylaja, who is a visiting scientist at Bangalore Science Education Association. Madam, am I audible?
You are audible to me, ma'am, Shailaja ma'am. Can you hear me?
Madam.
Hello, Shailaja ma'am.
I will make a call system.
Okay. Hi, we are unable to reach the speaker, so just give us 1 minute, then we will restart the session.
Hey, यार वो
Our speaker will join in a minute. So just to fix the internet glitches, wait for me.
Deepthi, would you be able to turn off your video? சுரேந்தர் கேக்குதா? சுரேந்தர் திருப்பி இன்ட்ரோடக்ஷன்லேருந்து ஆரம்பிச்சிடுங்க. ஓகே.
Hello.
Hey, hello Ramjeevan. Just wait for 1 or 2 minutes. Our speaker is joining. Just a minute.
Sir, Anupama ma'am class.
Okay, thank you. Just wait for a minute. Anu, do you want to speak?
Good morning. Good evening, sir.
Good evening.
Good evening, sir.
Good evening. Good evening.
Anupama
Yeah,
class.
Praveen.
Good evening, sir. Hello.
Geo Praveen.
Hello.
Hello, ma'am.
Hi, I'm going to request all the participants to stay muted. Um, if you have questions,
Hello.
Manish, I can hear you. Can you stay muted, please? Ramjeevan, can you please mute yourself? Thank you. If you have questions, feel free to unmute and ask. If not, please stay muted, okay?
Hello?
Sir, yes.
Hello. Hello.
Yeah. The meeting is going to start. Just some internet issue with the speaker. She's joining now. Just a minute.
Okay. Thank you.
Yeah.
So can we start the meeting?
Arun Bharti, just a minute, wait.
Surinder, maybe just notify in the chat to everyone so people don't ask the same question.
Yeah, no, just a minute. I will know. Yes, our speaker has joined. Just a minute.
Surinder, maybe just
I'm
Yeah.
extremely sorry. There was some problem with the connectivity.
It's okay, madam. Yeah. So, thank you very much. Once again, we welcome our guest, Dr. B S Shylaja, who is a visiting scientist at Bangalore Science Education Association, and who is another visiting scientist at Jawaharlal Nehru Planetarium Bangalore. Madam, it's time for you. Thank you. Yeah, you can start.
First of all, I apologize totally. And today I would like to tell you about the asteroid day, the importance, and why we should study the asteroids. I'm extremely thankful to Mr. Surinder for giving me this opportunity to talk to you people. Now I want to share the PowerPoint. How do I do it?
You are private.
How do I share the PowerPoint? Can someone help me? This is the first time I'm doing on Google Meet.
Okay, madam.
Can you see 3 dots?
3 dots, yes.
There will be screen share.
I will.
Yeah, it came.
Hey, students, wait.
Hi, ma'am. Good morning.
Students, wait. Madam, you can.
Please have like a good morning, yeah.
Ma'am, so if you see in the below options,
Should I go to full screen mode? Should I go to full screen mode?
no need ma'am. So if you see below, you will find 4 or 5 buttons. There will be one, if on the button, one of the buttons will say present now. Just after a button called CC, I think it's the 4th button that will say present now.
Okay.
Yeah, if you just click on it, you can select your screen and then you would be able to present.
Are you able to see the screen now?
Not yet ma'am,
No,
I think you have to
no,
select
no.
the screen.
Are you able to see the screen now?
No,
No ma'am.
I will show once.
No, Manish, it's okay. I'll check it out. Hold on, okay.
I'm so sorry.
Ma'am, is it okay if you can send the presentation to Surinder over email quickly? We can present it from our screen.
No, already we have lost 15 minutes. So sending is another. See, I opened the 3 buttons here.
No. Before that, there will be another button, ma'am.
First one is whiteboard. The second one is change the design or something. The third one is
No, not that, ma'am. So you have the audio.
Ram, wait. Madam, just a minute. From the audio button, you can see below, you can see audio button and video button and CC and present now button. Don't click that 3 colon button.
oh here. One
Yes.
window.
Yeah.
Okay. Now, is it okay?
Yes,
Are you
madam.
able
Yeah.
to see?
Yes,
Fine.
yes. Yeah.
Huh. So why do we need to study the asteroids? That is what I'm trying to say. So this is something very general about the solar system, which all of you know. Anyway, we have 8 planets and many dwarf planets and so on. And where are the asteroids? Asteroids, generally, by definition, they are between the orbits of Mars and Jupiter. That's what you think, okay? That's the definition. So it's called the main belt asteroids. And there are many dwarf planets. Ceres, for example, was considered as a dwarf planet. See, it was discovered 200 years ago. At that time, it was called a planet. They declared it a planet. Then they realized that no, it is not a planet. Starts with Ceres, and this is the orbit of Ceres. So it is not to scale. So this is the main belt. This is called the main belt of asteroids. So the study or the words asteroid begins with the study, and this is the person who discovered it on the 1st January of 1801. So then,
Madam,
yeah. Any question?
no, madam. Just your screen. The slide is not moved.
What are you seeing now?
As the first slide, asteroid, the need to study them.
Oh, why did this happen?
No, you have to go for a presentation mode so that you can change the slide.
I have done that. I am on full screen here on my computer.
Okay, ma'am, just a quick thing. You will have to stop sharing a screen again and reshare, but select the presentation window instead of the PowerPoint window.
Ma'am, I can't.
1 minute, Manish, we are checking it.
There will be entire screen share option, madam.
That's what I did.
Yeah, just.
Is it okay now? Are you able to see?
Yes, madam. We can see the screen. You just move to the from the beginning. Yeah, it's visible.
Okay.
You can share it. Yeah.
Now, are you seeing the next slide?
Yes, madam. Yeah.
Okay, now I was here. I was telling about the discovery of Ceres, the first asteroid, and this is PSG who discovered it. Okay, this is what I was telling, that he discovered it on the 1st January of 1801, 220 years ago. And then so many other similar bodies were discovered, and finally they had to group them into a separate thing, so they were called minor planets. And subsequently the more asteroid got stuck onto it, and so on. Okay. So where are these asteroids?
Yes.
Points. I think you know about Lagrangian points more because of the James Webb Telescope. So any two bodies, Sun and Jupiter, they will have 2 points on the orbit which are having equal gravitational potential from these two bodies. So these are called the Lagrangian points. There are 3 more points, one here, and one here, and so on. But for the time being, we will concentrate only on this L4 and L5. There are many asteroids which are trapped here. They are called the Trojan asteroids. They share the orbit of Jupiter. So as Jupiter moves in its orbit, these also will start moving in the same orbit. So that's why they are called Trojan asteroids.
Good evening, ma'am.
Any question?
No, madam, just more. Some students.
Okay. Then there is another belt of asteroids which are beyond the orbit of Neptune, and this is called the Kuiper belt. Now these are, as you can guess, long period orbits. And
Evening, ma'am.
there are many bodies in this region also. So mainly we have no, if somebody is speaking, I can't quote if they're asking question.
No, madam, you can go ahead. There are some unmute things.
Okay, fine. So now generally there are these two belts. One is the main belt.
Douglas, please mute yours.
Okay. Now, how are the asteroids discovered? So, what is the main criterion for any solar system body? How will you know that a particular dot you are seeing in the sky is belonging to the solar system? So, we have the simplest method, namely, just keep observing it day after day. Its position should change. You know that the position of moon changes every night, the position of planets change every night, and so this also will be changing. But then these bodies are so tiny and so faint that you need a telescope. And how people discovered it? For example, how PSC discovered it. So he took a photograph of the same region of the sky at three consecutive or 3 or 4 intervals and compared. All the stars were matching dot by dot except one. So that I will show here. See, watch the arrow. Are you able to see the arrow? Red arrow which is showing the position of the dot. So these are taken at 3 different intervals, and you can see that all the other stars are in the same position, but this dot is changing the position. So this is how the asteroids, and for that matter any solar system body, will be discovered. As you can see, it's a very faint body, and so it requires special instruments to discover them. Nowadays you have digital images, so you can do this on digital images, but in the olden days they had a special instrument for this. So this was the instrument. It was called a blink comparator. So what they would do, they would put 2 plates into these 2 sides, and you will see it with binocular type of eyepiece. You see one here and another here, and when you switch between the two with the gadget here, there is a knob here. Once you see this and once you see this, then it appears that one dot is going back and forth. Then you identify that dot and find the coordinates of that. Then go to the next 2 sets of plates, find the coordinates again. Then with the help of the coordinates, you can find out how exactly it is moving in the sky. Then you can calculate the orbit and so on. So that is how it was done, and that is why it used to take so much of time for any discovery. Suppose you take a photograph today, you will get to know about the result only tomorrow or the day after, because it was a very tedious process in those days. Now, basically, we have to understand the nomenclature that is used in the context of the small bodies of the solar system. So, all of you know what is a comet. So, I don't have to explain. This is the comet. And you have meteoroid. Meteoroid is a smaller body. It can be a few centimeters thick, or it can be a few meters thick also. They are called meteoroids. What are they? They are floating in the solar system in between the planets. Then you have the asteroids, which you can say a very large meteoroid, but then the dimensions are of the order of kilometers. Like something like the hill, a hillock near your place. So like the Chamundi Hill or Nandi Hill or some such thing. So it's a huge thing compared to the meteoroids. Then you also hear the word meteor. What is a meteor? When these small bodies like these meteoroids, when they come and enter the Earth's atmosphere, because of the friction, they burn up in the sky.
Hello.
Then they produce a streak of light because they are burning and moving in the air. That streak of light is called as the
Kengeri
meteor.
metro va.
Then you also
Then
have the
take
word meteor shower.
take the same metro to
Now,
Majestic,
this is
and Majestic in the. Okay, babe, I am in the call. The session ನಡೀತಾ ಇದೆ. ಓಕೆ ಆ್ಯಂಡ್ ಸೆಷನಲ್ಲಿ ಇದ್ದೀನಿ. ಐ ಆಮ್ ಡೂಯಿಂಗ್ ದ ಲೈವ್ ಸ್ಟ್ರೀಮ್. ಏನೋ ಇಂಪಾರ್ಟೆಂಟ್ ಅಂದರೆ ಟಾಕ್ ಅದಕ್ಕೆ. ಓಕೆ ಹೇಳಿ, ಏನಾಯಿತು?
We had something like 200 per hour. So that was something very interesting. People enjoyed it. So it's something like fireworks in the sky, but every year you have them, but not all of them are as spectacular as the one we saw in 1999. Then you also have a fireball where it is a very bright streak of light. I mean, it becomes so bright that it becomes as bright as daylight for a few seconds. And bolide is something which actually explodes. So all these are the things that happen in the sky, but the moment this lands onto the ground, it will be called a meteorite, because what lands on the ground is a stone. It's like any other stone you find on the earth. So these are the different names that are used. How will you remember them? If a rock just passes by, it is called an asteroid. If the rock burns up in the atmosphere, it is called a meteor. Okay? But if the rock hits the ground and you recover the stone, then it is called a meteorite. So these are the different types of names that are used in this. Then we have what are called near-Earth asteroids. They are subgroups of the same asteroids, but then their orbits are so different that they come quite close to the Earth, dangerously close to the Earth. So they are called potentially asteroids, potentially hazardous near-Earth asteroids. Now, you look at this image. This is some kind of a graph, I should say, and you can see the orbits of Earth, Mars. This is Mercury, Venus, Earth, and Mars. What are these dots? The red dots are the ones which come very close to the Earth. They are the potentially hazardous near-Earth asteroids. And the green dots here are all the main belt asteroids which are quite safe. You don't have to worry about them. Now, with so many asteroids coming close to the Earth, there is always a danger. They can come and hit the Earth. That is why studying them has become very important now. First of all, how are the asteroids formed? Now you know how the solar system was formed. It formed out of a huge mass of gas which was rotating slowly, and because of the rotation, the entire mass concentrated towards the center, and that became the sun. And some matter which settled onto some kind of a disk on the plane perpendicular to the rotation. So the planets formed out of them. And there two kinds of processes could happen. One is gravitational collapse, the other is some kind of a diffusion, depending on which is more predominant. If it is gravitational collapse, then a rock will be formed. If the pressure is more and if it is not able to achieve the kind of collapse, then it becomes a diffuse body with the smaller pieces. So they are all distributed in that belt between the orbits of Mars and asteroid. So these pebble-like things were the ones which formed originally, whether the pebbles got together and formed an asteroid, or whether they are distributed and they have lost all the material which was there on the surface and in the vicinity. That is something that we need to understand, which in turn will tell us about the formation of the solar system itself. So what are these asteroids? It is something like cosmic refugee camp. First the large planets were formed, then the small planets like the Earth and Mars were formed, And those pieces which were thrown from these refugees, which were thrown out, they went and settled in the asteroid belt. This is one theory. So you have two different types of asteroids, S type and C type. This is based on their chemical composition. So S type were scattered from the rocky planet zone, that is the zone of the inner planets, and the C type were kicked from the Jupiter Saturn region. So that is how the refugee camp was built up, and all these bodies have settled in the main asteroid belt. So this is one of the theories. Okay, then how do we study these asteroids? As I showed in the first picture, there's such tiny dots. So how do you, and they are visible only for a few days. Then they go farther and they become fainter and you are not able to see them anymore. In that case, how do we study them? So there are four different methods. One is called imaging, which is just taking the photograph. And then spectroscopy. I suppose you understand what is a spectrum. For example, the spectrum of sunlight is called the rainbow. So the rainbow tells that sunlight is made up of 7 colors. It also tells that what are the chemical compositions of the sun. So if we take the spectrum of any asteroid, we will be able to get the details of the asteroid also. Then there is another technique called radar spectroscopy, and another which is a very interesting thing called the occultations. So I'll very briefly describe these methods. And the picture that you are showing here is a Japanese handheld camera, handycam, which has been converted into taking spectroscopy. That is, you see some kind of a reflection grating here. Grating is something like your CD or DVD. If you turn your CD towards light, you can see the colored bands in the reflected light. That is the spectrum of the light source. So you can just for fun, you can turn it to the sun once, and then to tube light once, and to another incandescent bulb once, and you see that there is a difference, and that tells you something about the source of light. This is a very simple statement I am making. So this is the handycam which you use for tracking the when the object is visible in the sky. So suppose it is passing, the near Earth asteroid is passing, it will be visible for a few minutes. Then he moves this camera along and then tracks it and then registers the spectrum of this asteroid. This is what he did. And this is how the spectrum looks. I don't know if you can understand anything, but then what you can read there are the elements OH. OH is the hydroxyl, Mg is magnesium, Ca is calcium, and sodium, oxygen, nitrogen. All these things you can see in the spectrum. This is how the spectrum will look in the handycam thing. This is a real spectrum of a meteor when it was going, and he took this. So this tells you so many things. One, about the particle which enters the atmosphere. The second thing is about our own Earth's atmosphere. The nitrogen 2, for example, N2. That is something which is present inside the Earth's atmosphere. So now you take the spectrum, take out those things which are contributed by the Earth's atmosphere, then you will know what is it that is contributed by the asteroid. And this is another similar thing that has been taken. You can make out the colors there. The colored bands are all of the stars, whereas the one in between, this one, is that of a meteor. You can see that it has more of yellow color. So it is showing, it is giving you some information about the content of the asteroid. So the sun, if we expect that the sunlight is the one that is reflected from these asteroids, and therefore it should be similar to sunlight. After all, if you put a mirror and see it, it will be the same, isn't it? But now this is how the sun's spectrum. We think that the sun is made up of 7 colors, but if you are able to resolve it with a grating, you can see all these dark lines which are representative of the chemical composition of the sun. So if you see these dark lines, that means these elements are present in the sun. So if you see the reflected light, that will also show these lines. That is what you expect. But then you see what you see is slightly different. So now you see there is a difference. So here you expected to see dark lines like this, but then you saw some more things here, some dark regions here. So this is converted into a graph. One is the reflected sunlight, and you see in the infrared region there is a difference. That difference shows what is contributed by the asteroid. So this kind of a work is done by astronomers to identify what is present in the asteroid or the meteor. And based on that, they have found that it behaves funny. That is, each asteroid looks different in the spectrum. So based on that, they have given some names like E-type, S-type, M-type. These are all the subclassification of the asteroids based on the spectrum. So what there is a difference. Some of them have more of iron, some of them have more of carbon, some of them have more of silicon, and so on. So that difference they are able to make out from the. Now you see this is for asteroids and this is for meteoroids. So now you see that there is a similarity, but then there is a difference also. So if it is an asteroid, it's a larger body. If it's a meteorite and if it shows something exactly similar to that, you can say that it is part of an asteroid which broke into pieces and one piece entered the Earth's atmosphere and so on. And this is how they are distributed. So this is the distance from the sun. That means closer to the sun, you have S-type, and far away from the sun, you have these C-type. And this is what I told you earlier, that the refugee camp has inmates from the inner solar system and from the outer solar system. Both of them have settled there in the main belt. So that distinguishing factor is this S-type or C-type, which you get from the spectrum. Now this is the radar imaging. There are many facilities all over the globe to send radar beams to an asteroid and get the reflected thing recorded. For example, on the way to Tirupati, there is a setup called MS Radar Facility. There also they can do this thing called the radar echo. So you send the radio beams, and when the asteroid is close enough, you can get that reflected thing, and based on this, you can do some kind of a mapping. What is the size of the asteroid, whether it is rotating, if so, whether it is rotating like this or rotating like this or like this, or whether it is toppling like this, and what is the approximate size perpendicular to your line of sight. So for example, whether it is like this, or whether it is like this, or whether it is like this, or whether it is like this, you will be able to make out that from this kind of a study. So this is very popular, and whenever there is a passage of the asteroid closer to the Earth, they use this idea to get the image, the size and other estimates of the asteroid. So this is one example for of an asteroid, and then you see here, once when it was taken, it was looking like this. That means you are seeing it like this. Let's say you are seeing it like this. At another time, when it came again, it was like this. So it was rotating like this. So combining these two, they were able to make a three-dimensional model of the asteroid. So as you can see, it is a very odd-shaped thing. It is not a spherical body like the planets. This is one typical record of this radar imaging, and from this, picture like this. This is can pass in front of a star, then the star is held is not visible for a certain period. Now, let's say an asteroid comes in between. So here is the star very far away, and the asteroid passes in front of the star. So people in this region, there are 5 observers. Let's say here, these 5 observers see that the star is invisible for a few seconds. It can be a minute, it can be 20 seconds, it can be 25 seconds. And for that interval, it is missing. The star is missing. Then it reappears because the asteroid passed in front of that. This is a very interesting technique. Using this, you are able to map the size of the asteroid. So this is how it is done. See, for example, there are 7 observers watching the event. Observer 1 will see the star coming up to here. The star is visible here. It was missing for a few seconds, then it reappeared, then again went missing and then it reappeared. What about this observer 2? It was missing for, say, let's say 45 seconds. For this fellow, it was not 45 seconds, it was say 5 seconds here and 10 seconds here, and in between it was visible. Now, observer 3 also was had noticed that the star was missing for 45 seconds, but the time was different. The timings were different. And what about this observer 7? Observer 7, he did not find any change in the star's brightness at all. Now you combine all these things based on the timings and the exact duration for which it went missing, then you can get this size and the shape of the asteroid. So this is a very powerful technique, and this doesn't require a very large telescope, and you don't even need to track the telescope. So if you can identify that star, just keep photographing that region of the star and then note down the timings very precisely. Then there is a network of amateur astronomers who will join all these observations and find out the shape of the. So this has been very popular, and many asteroids have been observed like this, and there is a network which is working on this with people with small telescopes. They do this job, and this is called IOTA, that is International Occultation Timing Association. This is the website, and you see this is how the records are. For example, here you see that the star was missing for this duration, and that was the name of the asteroid, Fringillia. And similarly, in all these cases, you notice that suddenly all the other star trails are complete, but one has a blank like this. And you see here, Lydia, it has been missing for a good number of seconds. So combining such observations over years, they are able to get the size of the asteroid, which is very interesting. So these are some examples. This is the asteroid which is named as Cleopatra, and in the year 1980 they first attempted this. And see, this is the result which has been used to compute the size of the asteroid. And it happened again in the year 1991, and then they found that the shape is like this. So now you see, you combine this and this, you see that it is like a potato. Once you saw one side, one view, another time you saw the perpendicular view. So you are able to get the sizes of these asteroids. And then there are these binary asteroids also. That means you know the Earth and the Moon system, you know the Jupiter and satellite system. Similarly, there are 2 asteroids, one going down the other. And such things also is very Galileo. You remember the name of the Galileo as the first spacecraft which passed through this asteroid belt and started orbiting the planet Jupiter. And on the way through the asteroid belt, it observed many asteroids. And for the first time, it observed this binary asteroid. That means already these are small bodies. Even among these small bodies, there are ones which are gravitationally bound and going around each other. And that is another, how did it happen? Whether they got entangled or did they break into pieces and start going down? All that information will tell us about how they were formed. Now, as I mentioned earlier, the asteroids can come and hit the Earth. Now, this is the impact crater in Canada. When they come and hit the Earth, they depending on the size, a huge crater is formed, and eventually water will fill, and then you will have them as lakes. So there is a lake in Maharashtra called Lonar Lake near Aurangabad, and that is a meteorite which went and hit there. Now here you have in Canada two side by side, so they think that this must be because a binary came and hit. So there are two of them, and there is a similar one in Germany also, just next to each other. They are not connected to each other. There are two lakes adjacent to each other. And when you see it as a natural body, for example, let's say a river is flowing, and for some reason the river is making two lakes, is emptying itself into two lakes, then they are connected. But in this case, they are not connected. So they believe that this must have happened because of the impact of a binary asteroid. And we had another impact in the year 1908. In fact, June 30 is observed as Asteroid Day because it happened on 1908 in Tunguska in Russia. It was a forest area and not many people were living in that region, so the catastrophe was not known. But subsequently, after many years, when people went and saw, they saw that all these trees had sort of broken at the same height. So it was, but people had seen the explosion, and they had heard the explosion also. But because it was a forest area and nobody had been living there, so it was not known. But after many years, people came to know that this must have happened. That means a meteor or a comet or some such small body came and hit the Earth, and that is why all this chopping off has happened. And then happened at one place forest. All these studies were, when you see a tree, you the development and also. And here in this particular tree from this region, you can see that because of the 1908 impact, you can see that some crack lightning has happened here. And afterwards, the tree survived and it started growing again. But before that, because of this thing, it had developed a crack. So this is a vital information. This kind of a tree ring study has been used not only for meteorite impacts, but also for sunspot variations and so on. These three people have been remembered for their study of the impact. Why? You see the impact not on the Earth, because on the Earth they're all filled with water. They're like lakes. Whereas on the Moon, you see so many craters. So people earlier believed that all these craters were because of volcanoes. But it was this person who is in the center here, is Shoemaker. He was the first one, Eugene Shoemaker, who first proposed the idea that there should be impact craters. This was in the early 60s, that means 60 years ago. So in the first Apollo mission, he suggested that these kinds of studies should be made, and when you bring the rock samples from there, you will be able to get this kind of analysis. When you do this, you will be able to get an idea of the impact that has taken place, and that turned out to be true. So today we know that almost all the craters on the Moon and a good number of them on the Earth are all because of this impact. That means a lot of stones coming and falling on the Earth almost every day. Okay, so This is Shoemaker. This is Levy. So these three people are known for their study of comets and meteorites. And they saw one interesting object in the year 1993. So they were photographing the sky and they found one object which they thought must be a comet. And it was looking like a cigar. It was not like a dot. It had a extension. And okay, this is the Shoemaker's theory of crater, how the craters are formed, and all these have been verified now subsequently with the study of moon. And this is what I was telling. So when they looked at the comet, they found that the comet was not one, but it had 21 pieces. The comet had broken into pieces. And all these 21 pieces went and hit Jupiter. That means their theory, namely that objects go and hit planets, was proved. And they were able to, Hubble Space Telescope recorded this, and they were able to time the event. That means when will piece 1 go and hit Jupiter, when will piece 2 will go and hit. So this went on for one whole day, and all these events were recorded by the Hubble Space Telescope. So the impact theory was successful in explaining this. And this is a photograph from the Cassini. Cassini, is the another satellite which is going around the planets, or Saturn, and it photographed this region on the satellite called Europa, and there also you can see a chain of craters, which means that this impact is common. Something breaking into pieces and crashing is very common. So this is what it means. So impact is something that we have to take seriously. That's the message from this. So okay, this is the method of aging of the surfaces. So if there is something which is coming and falling, what it does, it throws the material out. So by collecting the samples from the region, you can make out how long ago this has happened. So this branch of science is called astrogeology. So that is the new branch which is being studied now with so many space missions available. It's not uncommon. So this is a village in Bihar called Mahadeva, and there in the field they saw this, and then they had also heard the explosion in the night. So when they came to the field, they saw this, and they opened it. They dug it open, and this is the stone which had gone in. And so it's very common. Even last week there was a report that somewhere in Rajasthan a stone fell, and they were able to see it. And similarly, and now this is in the museum. They have put it in the museum there. Okay. Then this is another place called Mukundapura in Rajasthan. This was in 2017. And these were the pieces they were able to see. So just before crashing, it broke into pieces. You can make out the size of this. Here is the person's foot, the person who is collecting. So you can make out what is the size of these pieces. So when it breaks fresh, the inside portion is exposed for the first time. So whatever history it contained from its time of formation, all that you will be able to study. So people usually go and pick up these stones and study them in the lab and try to analyze what is special about this, when it was perhaps formed, and so on. So this is the close-up view. As you can see now, this is a freshly cut surface. So you can see that just before this, it broke into pieces. So this area was exposed to the sun before, whereas these two areas were not exposed to the sun before. But all impacts need not be so peaceful. So for example, if an asteroid comes and hits the ocean, let's say, then this is the height of tides that you can expect. the water will rise. So what happens to all these towns in the coastal area? They will all be flooded for good. I think that is the end of the town. Well, it may hit on the ground. If it hits on the ground, then the debris itself is sufficient to throw the dust and block the sunlight for a good amount of time, disturbing the entire biological cycle on the earth. So this is the reason why they think that the dinosaurs extinction happened. So whether an asteroid hits the ocean, again life perishes. If it lands on the earth, also life perishes. So either way, it's going to be a very dangerous thing, and not like the ones which I showed before, Mahadeva and Mukundapura. They need not be very peaceful. They can be very dangerous. It depends on the size of the body which is coming and hitting the earth. Therefore, there is a concern. So this is the 10-year-old famous picture of from Russia, where they were able to see this bright flash of light, and many people caught this on the video cameras, and they could see that thing blasting in the air, and it shattered some glasses and so on. And what is the energy? Energy is 30 times that of the Hiroshima blast. So these are the numbers, if you can understand. You see the Hiroshima thing is 10 to the power of 13, 10 followed by 13 zeros. Whereas an earthquake of Richter scale 8 will be 10 to the power of 18. But an impact is 1,000 times more than that. And therefore, you have to be worried about it. Impact. So how do we mention here everything that is dangerous? So the question is, now there is a serious concern about this, and they are trying to discover the near Earth asteroids that are approaching us. And you see, this study has picked up speed since 20 years. In the year 2000, we had only a handful of asteroids discovered. But see, by 2020, this is the size. Small bodies, and then these are the larger bodies of 140 meters, and these are much larger bodies. So year after year, we have been gathering information on the near Earth asteroids, and we are seeing that so many bodies are approaching the Earth. So we have to do something about it. So how can we save the Earth from such catastrophe? So there is this Lincoln Near Earth Asteroid Research Program, where they have many automated telescopes. If a small streak of light is moving in the sky, then the streak of light will be tracked by these telescopes automatically. They follow it, and then they send the signal to various other bodies of the other telescopes on the other part of the globe. For example, another in Australia, another in Japan, and so on. They also will start tracking, so that you will know precisely what is the orbit of this particular streak of light. So an asteroid is passing. Now you calculate the orbit and estimate that after 5 years it will come back again. After 10 years it will come back again. At that time, what will be the approach? Whether it dangerously close, or it will go far away so that you can be relieved of that effect. So this is being done, and this is another interesting experiment that was done by a spaceship called Deep Impact. So what it did, it went close to this is a comet, a small comet. It went close to it and threw something onto it, and that something exploded there, Now, what happens when something explodes? The recoil velocity will push the body back. So, whether this kind of an effect is noticeable at all. To monitor this, they did this experiment, and the impact energy was 19 gigajoules. It's not a small amount. And because of this, what was the change in the size of the orbit of the impactor, that is the body, the comet? Just 10 centimeters. Now you imagine what is the amount of energy that is needed for these kinds of. That means you see in fiction that there is a body coming close to the earth, it is likely to hit the earth, and therefore you shoot a impactor like this, which goes and blasts itself there, and therefore the body goes away. This is all happening in the movies. But then, what is the real numbers that you are working on? With 19 gigajoules of energy, you are able to move it only by 10 centimeters. So, and then you won't be able to know about this maybe months in advance or something. It may give you only 3 days, because they are very small, they are very far away, and you are not able to see it. But only when they come close, you will be able to see them. Okay. So this is another method they are thinking. So they send a satellite to this asteroid which is coming, which is potentially dangerous. And by adjusting the speed of the satellite and the revolution period, you can impact a small amount of energy onto it so that it moves away from the Earth. So this is called gravity tractor. This is also hypothetical. No such experiment has been done so far. This is another interesting scheme where again the recoil velocity is being used. So you have a focuser which will focus the sunlight onto the asteroid, and you see that it vaporizes a lot of material from that, and in the process it takes it away from the Earth. So essentially here also you are using the idea of recoil velocity for this purpose. Okay. So these are all methods by which we can save the Earth, but these are all not generally practical, because you should know beforehand, that they are going to hit the Earth. So far, only 3 or 4 asteroids are recorded. Their orbits were very well known, and the date of impact also was very well known. One is called Peekskill, the other is called Pribram or something, and the third one is called Innisfree. These three, the orbits were very well known beforehand, so they were able to track it, and it fell fortunately into the ocean and nothing serious happened. They were all small bodies. But otherwise, it is a real concern. So in order to save the Earth from such impacts, these programs will have to be originated. This is one important study of the asteroids. So you had Osiris Rex, which visited an asteroid called Bennu. It went and picked up some things and brought it back to the Earth. So all these are being done to see the structure of the asteroid, whether these kinds of experiments are possible or not. Now, I'm taking you back to Ceres, with which we started, because there was a space mission called Dawn, which went close to Ceres. And then it moved further to another. So this is the orbit of Ceres. So now here you see this is going close to Ceres. And then it gave us so much of information about Ceres. And what is this? Because Ceres is something different. All the while I had been showing you photographs of asteroids which were looking like potatoes, small body. But Ceres is not a small body. It is quite sizable, and it has almost a spherical shape. The spherical shape will be possible only when it has sufficient mass. That means there are many massive bodies like Ceres in the asteroid belt. You can't take them lightly. They will not break into pieces in our sky, but they can cause real serious problems if they come close to the Earth. But basically, how did they retain that kind of a spherical shape? What is making them different from other smaller uh, bodies like the Bennu or other smaller bodies, Lydia, all those names which I mentioned? So that is here we start and that why it is reflecting eyes there. Hopes of finding life there. So you can set up a colony there. That way also it is going to be a very useful study. So it can be a future colony for humans. So with all these points, every year the 30th June is celebrated as the Asteroid Day to tell people about the importance of this event of impact and the necessity for saving the earth from such catastrophe. Okay, so this is what I'm trying to convey. I did not go into the theory of how they are formed and so on because it's all mathematical. But right now I have conveyed to you, I hope, the need for the study of the asteroids. So thank you. If there are questions, I would answer.
Yeah. So thank you very much, madam. It was a really wonderful talk. The floor is open for questions. Participants, you can ask questions. You can just unmute one by one. You can ask questions. Yes. Any questions from the participants?
Please read out if they have written in the chat box.
Yes. Just I'm opening the chat. If you want, you can post your questions in the chat box also. Okay. So, yes. Yeah. What is mean by binary asteroid?
Is about each other. And they are not just floating and each other, so they are going around each other around the common center of mass. That's the meaning of binary asteroid. So as I mentioned, whether they were formed together or it was a single asteroid which broke into pieces, we do not know.
Yeah. How to avoid an asteroid that would enter Earth?
No, that's what I explained. There are many methods which are being contemplated. So far, none has been attempted practically because the asteroid doesn't give that much of time. No, you have to plan a mission for that. It is not like the border security force just jumping into a jeep and running. No, it's very difficult to plan any such move to the space.
There is one more question from Abdul Pot. Do planets an asteroid?
Can you repeat?
Do planets other than Jupiter have Trojan asteroids?
Well, once they discovered Trojan asteroids for Jupiter, they started searching for them in all other planets, including the Earth. But not many of them have this many asteroids, because for Jupiter there are thousands of them. So for Earth, they found that there is only some gas which is contained there, not an asteroid. So similarly, other bodies also have small particles which are trapped in that point, and they keep following the planet in the same orbit.
Okay. There is a question from Pratik Chakraborty. Are there any chance of collision of asteroid? I think in recent days, maybe he's asking like that.
Now, I suggest you look up um, a website called Space Weather, something like that. They list potentially hazardous near Earth asteroids and close to Earth. They give tomorrow. If the geologically listed in terms of as one unit. So with it is, so they usually give that, and people follow that and try to track it also. That is also that. This is available on the internet.
So another question. That's a question from Lalit Vikraman. Ma'am, what is the difference between comet and asteroids?
No, they are two different bodies. The way they are made is different. Asteroid is a solid rock, whereas comet is very loosely held up. This frozen dry ice and water ice usually cement them together. So when they come closer to the sun, all these materials will evaporate and it breaks into pieces very easily. Comets are very fragile, whereas asteroids are solid bodies. They are not held that way. So the very way they were formed are quite different. The chemical composition itself is different.
One more question. Arun Bharati asked, Ceres is the first asteroid. Maybe he's asking like Ceres is the first discovered asteroid.
Yes. What is the question?
Does Ceres is the first asteroid.
Yes.
Yeah, that is the question. That's all.
Good evening, ma'am.
Yes.
Ma'am, I'm Chandana. I'm doing my 8th grade now, ma'am. I'm from Alchemy Public School, Tamil Nadu. And the session was so nice, ma'am. I learned many things about asteroids and meteoroids. Meteoroids from will it be economical?
It's not easy. Even what will you do with such tiny rocks? That kind of application you can't think of immediately, because they are not. It's not equivalent to mining. You go to a planet and start digging there and collect some rare metal which is not found on the earth or something. No, it's not possible to do with these small rocks. No.
Okay, ma'am. Okay, ma'am. Thank you, ma'am.
Thank you.
Sure, Chandana. Any more questions?
Okay, if there are no questions, I thank you and the organizers, Mr. Surinder. I am thankful to you for giving me this opportunity to talk to the young people and learn about their interests, because
Yes.
it's a very fascinating subject. I hope they will all be inspired to take up this seriously and study in their future classes. Thank you very much.
Yeah. Thank you, madam. Thank you very much. Yeah, it's really wonderful time with you. Thank you once again. And on behalf of Chiguru Colab, we thank everyone for your wonderful evening with us. Tomorrow we are going to have another wonderful talk from Professor Ilangovan, who is going to talk about dynamics of asteroids. So do join us tomorrow at 7 o'clock. So thank you again, madam. Thank you very much for your amazing time. Thank you, madam.